Today we shall see an example of SVM classifier. We are given a binary classification problem, that is, we have two classes which are linearly separable, and since it is a supervised algorithm, we are given the input and the corresponding output. Input is x1, output is y1. Here the y values take either +1 or -1 values. Since it is a two class problem, the two classes are +1 or -1. Please note this is -1. Okay. Now the algorithm goes like this. So here we are using a linear classifier or linear SVM classifier. So it uses the equation of a straight line, that is y is equal to mx plus c, or m into x plus b equal to 0, or we get the function of the or the discriminant function is given by f of x is equal to w into x minus b, where w is a weight vector and b is a bias. Now in this algorithm we shall compute the weight using this equation, where x is the input, y is the output, and alpha is an additional term which we need to compute. Okay, and we shall compute the value of bias b using this equation. So we got to find that alpha, which is a vector, which will maximize this condition subject to this constraint. Okay, so this is the SVM algorithm. Here is a problem. We are given the input values as well as the desired output. Input is a set of points, so we have x and y coordinates. So we are using x1, x2 to represent the input points. There are two samples given and the corresponding class to which they belong to. So the first point, or the vector x1, the point is given by 2, 1, and x2 is given, that is 4, 3. x1 belongs to the class 1 and x2 belongs to the class -1. Now we are assuming another vector alpha which will have two values, say alpha 1 and alpha 2. Now we got to compute the factor phi of alpha using the previous equation. So that is sigma I is equal to 1 to n alpha I. That makes it alpha 1 plus alpha 2 minus 1 by 2 alpha I, alpha j, yi, yj, xi dot xj. So while computing, what we get is the values alpha 1, alpha 2 are unknown to us, or we got to maximize the value of alpha. So let us write them as such: alpha 1 plus alpha 2 minus 1 by 2 alpha square into, it is y1 into y1 x1 dot x1. Now let us take the values of x1. x1 is 2 and 1, so that makes it 2 into 2 plus 1 into 1, and y1 is +1, so it will be +1 into +1, 2 into 2 plus 1 into 1. Similarly, we got to compute the dot product of x1, x2. That will be 2 into 4 plus 1 into 3. We have 2 into 4 plus 1 into 3, and y1 into y2. That will be +1 into -1. Now, when we calculate and expand, we get this equation. Okay, or this is subject to this condition, that is this alpha 1 minus alpha 2. Now to maximize this, we can set this equal to 0, which makes it alpha 1 equal to alpha 2. To find the required values of alpha 1 and alpha 2, we got to apply this obtained result, that is alpha 2 is equal to alpha 1. So replacing alpha 2 with alpha 1 in the previous equation, we get a new value of phi. Phi is obtained as 2 alpha 1 minus 4 alpha 1 square. So we got an equation in terms of alpha 1 alone. Now for this function phi to be maximum, we got to differentiate it with respect to the unknown term, that is alpha 1, and equate it to 0. That is, we take the first derivative, that makes it 2 minus 2 into 4 alpha 1, that will be 2 minus 8 alpha 1, and equate it to 0. When we solve this, we get alpha 1 as 1 by 4, and we already have alpha 2 equal to alpha 1, so that makes alpha 2 equal to 1 by 4. Okay, so for this value of alpha, we can find that the second derivative will be less than 0, or the function phi will be maximized. Now we go to the second step, where we compute the value of weight using this equation. Here alpha 1 is 1 by 4, alpha 2 is also 1 by 4. We know the values of y1 and y2, so we just got to add these two together. While adding, we add the x terms together, then we add the y terms together. So this makes it 1 by 4 into 1 into 2 plus 1, then minus 4 minus 3. So it will make it 2 minus 4, which is minus 2, and 1 minus 3, which is minus 2. Now dividing by 4, we have minus 1 by 2 and minus 1 by 2. Then now we find the value of b using this equation, or we've got to find the minimum value of wxi plus maximum of wxi. That will be minimum of this is computed. Here maximum is taken, and we just add them up and divide by 2 to get minus 5 by 2. Then now comes the last step, that is, we got to find the equation of the discriminant function f of x. It is a linear discriminant function, so we have wx minus b. So that will be minus 1 by 2 minus 1 by 2 into x1 x2 minus 5 by 2. We just expand this to get the equation of the line, equation of the separating line. Now equation of the maximum marginal hyperplane is f of x is equal to 0, or we assign this to 0 and rearrange the terms to get the value x1 plus x2 minus 5 equal to 0. Thank you.